Hi my dear learners, welcome back to the class. Let's have a look at what we are going to discuss in this session. In this session, we are going to learn converse of basic proportionality theorem and its applications. So, in depth we are going to discuss converse of basic proportionality theorem and its proof as well as and their applications. Let's start. Okay. Theorem. State and prove converse of basic proportionality theorem. Here is the statement, converse of basic proportionality theorem, saying that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. If you look at, this is exactly opposite to basic proportionality theorem. You can say reverse. Okay. So let's prove this one as well. So according to the statement, here you can see the figure. ABC be our triangle. DE divides AB and AC in the same ratio according to given information. Clear? So given triangle ABC and a line DE intersecting AB at D and AC at E such that AD over DB is equal to AE over EC. Let us get equation number 1. So you can see here the same information. In triangle ABC, DE intersecting AB line at D and AC line at E, and AD over DB is equal to AE over EC. It is given, right? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That is what we need to prove. Okay. Here we need to prove DE parallel to BC. This is parallel to this, right? Let's prove. Proof. In triangle ABC, according to given thing, AD over DB is equal to AE over EC, right? This we know. Let us assume that in triangle ABC, DE is not parallel to BC. So let us assume. So anyhow we need to prove DE parallel to BC, but here we are assuming DE is not parallel to BC. So in that case, there is a parallel line, right? There must be a parallel line. So draw a line DF parallel to BC which intersects AC at point F. Let's draw. Here we drew DF parallel to BC which intersects AC at F. Clear? Now on applying basic proportionality theorem, we get, since this line is parallel to this line, then other two sides are in the same ratio, right? So then AD over DB is equal to AF over FC, right? That is what you can look at here. AD over DB is equal to AF over FC. Let us give equation number 2. Now look at equation 1 and 2. AD over DB is equal to AE over EC as well as AD over DB is equal to AF over FC. So from equation 1 and 2, we can conclude AE over EC is equal to AF over FC, right? Since LHS parts are equal, then RHS parts must be equal, right? Okay. So from equations 1 and 2, we can say AE over EC is equal to AF over FC. Let us give equation number 3. Clear? Now, on adding 1 on both sides of equation 3, we get, so we are adding 1 to both sides, okay, in equation 3. AE over EC plus 1 is equal to AF over FC plus 1. So on adding, take LCM, EC. EC divides EC one time, so AE plus EC into 1, EC, right? So same you can see here, AE plus EC over EC. Here FC is LCM, FC divides FC one time, 1 into AF, AF plus FC into 1, FC. Now look at here, AE plus EC, what it is? AE plus EC, that is equal to AC, right? So we can write AC instead of AE plus EC, we can write AC over EC, and AF plus FC, you get here AF plus FC, again this is equal to AC, so AC over FC. So this is equal to this, right? So this fraction equal to this fraction. Numerators are equal, so denominators must be equal. So we can say EC is equal to FC. So this is equal to this. EC is equal to FC. So which means these 2 points are what? Coinciding each other. Got it? So we can say that the points E and F coincide on AC, that is DF coincide with DA. Clear? So this line and this line, both lines are coincide on each other. means lying on each other. Got it? Since DF is parallel to BC, we already know this, we have taken DF is parallel to BC. Since these two lines are coinciding each other, so DE also parallel to BC, right? So hence DE is also parallel to BC. That is what we need to prove. So DE parallel to BC, hence proved. So we can say in a triangle, a line divides other two sides in the same ratio, then the lines are parallel. Clear? Shall we discuss once again briefly? Yes? Okay. Here is the statement of basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So for that we took a triangle and a line which divides other two sides in the same ratio. According to given information, we have got AD over DB equal to A over EC. We have got one relation. Let us give equation number 1, and we need to prove DE parallel to BC. So for that this is already known information, and we assumed in triangle ABC DE is not parallel to BC. So we drew another line which is parallel to BC, that is DF. DF parallel to BC, which intersects AC at point F. Okay. So on applying basic proportionality theorem, because if a line is parallel to third side, then the line divides other two sides in the same ratio according to basic proportionality theorem. Then we have got another relation, AD over DB is equal to AF over FC. So we have given equation number 2. From equation 1 and 2, left side parts are equal, so then right side parts are equal. Then we have got equation 3. On adding 1 to equation 3 both sides, further we have got AC over EC is equal to AC over FC, and both parts are equal, so numerators equal, so denominators must be equal, so EC equal to FC. So which means we can say that the points E and F coincide on AC, then DEF coincide with DE. So we already know DF is parallel to BC, that we have taken, so then DE is also parallel to BC. So finally we have got DE parallel to BC, hence it is proved. This is what exactly the converse of basic proportionality theorem. Clear? So now by using this result, let's solve some example questions.